So today's lesson is all about the gateways, which are one of the most fascinating and confusing subjects when it comes to VeloCloud SD-WAN. Well, I remember when I started reading about the technology, I just couldn't get my head around them, why we use them, who's responsible for them, etc. So hopefully in this session, we can do a few whiteboards and I can actually show you the different types of gateways, no matter if they are primary, secondary, super gateway, SaaS gateway, partner gateway. Just to distill it in a short format, we use the gateways as a controller, right? SD-WAN is an software-defined solution, so the control doesn't really stay on each of the individual routers or edges, right? It's done centrally in order to allow for that scalability and flexibility. But we also can use the gateways to shift traffic, whatever that's between the branches, or when we communicate with any third-party sites or software as a service applications. And we do that in order to extend the benefits of SD-WAN for internet-based traffic. Something that's not possible if you're just using plain old direct internet access.
So let's talk first about the gateway as part of the control plane. Back in the old days, if we had a few routers in North America and a couple in the EU, we used to manage them separately, and we used to have to connect to each of them individually and set some command lines in order for them to connect to the rest of the estate, etc. Now with software-defined networks and software-defined WAN, we decouple the data plane, which remains on the edge, with the control and management plane. The management plane goes to the orchestrator and the control plane goes to the gateways. So in this example here, I'm going to show you how those two edges in North America and those two edges in Europe will use their respective gateways to learn about each other. Now, it doesn't really matter how they are connected, if with one or multiple circuits. I'm just going to draw one for the sake of simplicity. But the idea is when the edge registers to the orchestrator the first time, the orchestrator will assign a gateway, acting as a primary. Now, that is actually the gateway geographically closest to the edge. So for example, this gateway here can serve as primary for these two edges, but these gateways here being hosted in Europe actually are closer to these ones here. So they will be primary for these two. We have P2 and P1. The orchestrator uses this service called MaxMind in order to geolocate the IP address and thus make a decision to what gateway serves as a primary. Now, I did mention gateway pools before, and the idea of a gateway pool is simple. We have more than 2,000 gateways all around the world. We don't really want to use all of them for just a single customer that might just have, let's say, 50 edges, right? So when we create a customer account, when we create an enterprise, what we do is that the operator creates a gateway pool that might be, I don't know, 15 to 20 of these gateways. And it's all about the location because the operator will be aware where the customer has the sites, and it will start assigning gateways in those regions to make sure that the customer has gateways nearby. Obviously, if the customer decides to extend that and it will go in a new territory, then through the partner, they'll be able to request new gateways added to this pool. So going back to how the edge registers to the orchestrator finds the primary gateway, it will inform the edge to connect to it, and thus the edge will create a VCMP tunnel. It will send a tunnel initiation message to the nearest gateway, and it will create an overlay. So you'll see here, we have 2 overlays in North America and 2 overlays in EMEA. Now these overlays allow the gateway to start measuring the bandwidth. So we talked previously that one of the advantages of a VeloCloud solution is that you don't need to set the bandwidth manually. You can, but our recommendation for public circuits is always to leave the gateway to run these tests. So in case you have lower bandwidth than expected, the edges can learn that automatically via this process and make sure to enable things such as traffic shaping, not overload the link, thus making the packets drop at the next hop. Now, besides that, the primary gateway's role is as a route reflector, right? To make sure that this edge here knows exactly what's happening on the other side. So once you start enabling Cloud VPN, this will actually allow the edges to connect to one another, learn routes, etc. Now, obviously, the gateway is a single point of failure. We do take great care in VMware to make sure that they don't go down. But just in case they do, you then have this concept of a secondary gateway, right? Now, a secondary gateway is still very close to the edges, but it's not in the same point of presence. There is a distance of, I don't know, 50 or 60 miles between them. And just make sure that in case something happens to that public data center, both the gateways won't be impacted. So by default, each edge will also create an overlay and connect to a secondary gateway. So now we have local redundancy. But the question is, how can we make sure that the edges in North America can have visibility and communicate with the edges in the EU? How do they learn about each other? They don't have any gateways in common, right? For this, we have another concept, and that is the concept of the super gateway. Now, also the super gateway comes in pairs, so you have a primary and a secondary. But you just have this pair for the entire estate, no matter if you have 50 or 5,000 sites. When you create an enterprise from this pool, 2 super gateways will be chosen, and they will represent the last resort. So you'll see each edge connected to them. I will not connect the secondary, just to allow the picture to remain clear. But this will make sure that the edges that don't share primary and secondary gateways can still have the visibility of the rest of the estate. Now, if you go for the hosted model and you allow VMware to host the gateways, there is no way you can choose a certain gateway as primary and secondary. That's done automatically. However, you can always talk to the operator to choose the super gateway based on how your estate looks like in the long run. So for example, if you only operate in North America, one of these will be chosen as super gateway and secondary super gateway, that's fine. But if you're now shifting the operations to Asia and you reckon most of your estate will be in Asia, you can request through your partner, and that request goes to the operator, and the operator can manually move the super gateway. There is another option in which the partner can host the gateways. They're quite great as a multi-tenant resource. In this case, we call that a partner gateway. And you'll see things such as service providers who use that in order to resell services in their own data center. If you are running a partner gateway, you will need to manually assign the gateways to the edges, and you'll not be using the MaxMind IP geolocation service. Before I redraw this diagram, I wanted to give you the first example in which the gateway can actually be used as a hub, right? So use case number one, we use it as a hub. So hopefully you remember the lesson in which we talked about the hub and spoke topology and why you'd like to do that in order to minimize the size of the hardware at each of the branches. Now, this assumes you have a hub. This assumes that you have a data center in region. But what happens if, let's say, you have a few branches in North America, but everything else is in Europe, including your data centers? Obviously, you can go inside the cloud VPN and you can allow it to connect via the hub. Let's say your hub might be here. You can obviously allow the branches to talk to one another via the hub, like this. However, this might not actually be optimal, especially for real-time applications. So in that case, you can actually say that instead of using the hub in Europe, we'll be using the gateway. So in that case, the primary gateway is used, and at failure, we can use the secondary gateway. So this allows us to actually be more flexible and scalable in areas in which, again, we cannot deploy an edge as the hub. So what happens when I'm trying to still use gateways, but my edges don't have the same primary and secondary gateways? Well, obviously, we will use this super gateway. So in case you're using that across your entire domain, the super gateway, again, is the gateway of last resort. So let me redraw this to give you more examples of gateways forwarding data. So in the next example, we will be discussing how you can use a gateway to extend the benefits of SD-WAN when accessing software as a service. So let me show you what the problem is. We have a branch here, or even a teleworker unit. We are connected to multiple circuits to the public internet. And we're trying to access a software as a service resource. Let's say Office 365, it's a great example. So how does that usually work if you have a router? It might even be your broadband router at home, right? Your traffic hits it, you do a port address translation for the public IP addresses on the WAN interfaces. And then you are directed by Microsoft to the nearest location they have, right? So they don't want you to go and connect to an IP address across the country or on a different continent. They want you to connect to the closest point of presence. So if I'm here in East London, that might be possibly Central London. Now, as you can see, because you're not actually using an overlay, we can't take a smart decision based on the performance of these circuits. Secondary, because we don't have the overlay, we cannot use remediation techniques in case the links go bad. So we can resort to a simple thing saying, hey, let's do direct internet access, DIA, split everything based on a policy who says I'm preferring broadband. If that's not working, use the LTE. Some vendors do some sort of an IPSLA, which is a crude way of achieving this, but VeloCloud takes a step forward. So this is where the gateway comes in, because we locate them in these big public data centers. We actually allow you to take all your traffic, automatically connect via the overlay, and extend the benefits all the way to the front door of these providers. You cannot host your edge in these services, right? But with this, you can actually extend the overlay. And this is very important because most of the problems you'll see is not on the software as a service side. Companies like Microsoft, Google, Skype, etc., they scale their networks pretty well. The problem happens in this first mile. You might be stuck at home, so this is you contending with all your neighbors for kind of the same upstream resources. etc. So most of the problems that we see with today's networks actually happen when the branch is trying to get out to the internet. So in this case, by extending the overlay, we can use DMPO. So hopefully you have seen the lesson on DMPO and its advantages. If not, please do. And you can benefit from SD-WAN all the way to the doorstep of all these SaaS providers. So which gateway actually we're going to use? Well, we're going to use the primary gateway. It's the same gateway that you automatically connect to when you power up the edge. The gateway which is geolocated to be closest to you in the same way that in our example, Office 365 does. In case the primary gateway fails, let's say it goes down, the default behavior is actually not to use the secondary gateway. The behavior will be to use the direct internet access. So in case the primary gateway fails, again, you will not be using the overlays. You will just spit up the traffic directly. Now, the third example we're going to have is how you connect the edges to third-party sites. So these are sites in which you cannot put an edge. It can be a legacy data center. If you might be using infrastructure as a service and you cannot, for a reason, place an edge there and connect them just as a normal cloud VPN, or even if you're using cloud security services such as Zscaler and Symantec. So although later versions of code will give you the ability to connect the edges directly to these services, you obviously have to specify the public IP address or IP addresses. By default, we always go through a gateway for that. So we're gonna choose a gateway. We're gonna use the overlays to it to tunnel all the traffic. Again, if you want to learn more about the overlays and why you should be using it, please have a look at my DMPO session. And then we will connect that gateway with the third party. So this has a few advantages because not only you can utilize SD-WAN to protect most of the path, you have far less points to connect. So in this case, on this side, you don't need to configure each branch individually. You just need to configure the gateway public termination and off you go. Now, this gateway is not the primary gateway. This gateway is a different gateway chosen to be close to the third party. So you basically are replicating a hub and spoke topology, but rather than use the third party as the hub, you'll use the gateway that's nearest to it. And obviously you will have a primary and you can choose to have a secondary as well for resiliency purposes. And although we briefly discussed earlier the concept of partner gateway, I wanted to show you how it looks like, right? Because partners can choose to host their own gateways. And this usually happens when they resell certain services. You know, they might have a big private line in one of the public data centers and they are subdividing that. They might host voice or they might want to backhaul all the traffic and do a cloud security model. It doesn't really matter, right? What they're looking for is to bridge multiple customers with their shared services inside the data center. So in this case, rather than to have an edge per customer and complicate your life by making sure that routes properly, you deploy a gateway or obviously a pool of gateways. They have a leg up on to the public side, they have a leg into the private side, and every time you have new customers, you just manually make sure that they can connect with the same overlay concept to your gateways. And although I don't have time for now to go into partner gateway design, please note that you have the ability to segregate the customers, so to keep them separate. But even within the same customer, you have the ability to carry over the segments, right? So if you have a guest, a corporate, and a PCI VRF, which we call segments, that can actually be carried across here and routed appropriately into your shared services. So let's recap what we discussed. Again, if you didn't get some of these, is fine. Gateways can be a complicated thing to understand where you're new to VeloCloud, so don't worry about that. But basically, we have this concept of gateways as a controller, making sure that the edges can discover one another and can connect to each other, right? And the way that this happens is once the edge goes online, the orchestrator, based on its location, will assign a primary and a secondary gateway. They are not residing in the same point of presence. They are in different data centers, but somewhat quite close in the same region as the edge. And this is a redundant way to offer control to the edge, because besides the gateway helping the edge do the routing, it will also allow it to discover its bandwidth on each of the upstream links, thus create better quality of service rules across the circuits. Now, if the edges don't share the same primary and secondary gateways, well, they need to use the super gateways to route between one another. As opposed to the primary and secondary gateways, which can be different for all devices, the super gateways are the same for the entire edge state for a customer enterprise. And as mentioned before, although you cannot choose manually what your primary and secondary gateway is, you can request through your partner to move the super gateway in case the location is not ideal. Now, these gateways can also be used as hubs. So in case you don't have a local edge in region to allow the spokes to talk to one another, you can actually use through the cloud VPN the gateways. And this works from the same principle. If you don't share a primary and a secondary gateway, we will use the super gateways to route traffic between the branches. Now, if you're doing lots of software as a service and you're looking to extend the benefits of SD-WAN, you can then use your primary gateway as your SaaS gateway. Because the primary gateway is co-located in the same public data centers that big players like Microsoft and Google reside, we actually allow you to extend the benefits of DMPO and the overlays all the way to their doorstep. And this is not something possible with most other SD-WAN solutions. If the SaaS gateway fails, if the primary gateway fails, you will not use the secondary gateway. The edge will just do direct internet access. If you're connecting to any third party, whatever that's a legacy data center, and you have a router or a firewall that can do IPsec, or you might be connecting to infrastructure as a service and don't want to or cannot put an edge there, or if you connect to next generation security services like Zscaler, for example, you'll have this third party gateway, which is different from the primary gateway. We choose this based on the proximity of the third party. So we basically replicate a hub and spoke topology with the third party gateway being the hub and being as close as possible to the third party. So this gives you the opportunity to benefit from DMPO and also have minimal configuration on the third party side, because it will only connect to one or two gateways for resiliency. It will not connect to each edge individually. And if you're a partner and you're looking to resell shared services and you like to take advantage of the flexibility and the multi-tenancy of the gateways, you can host your own. There's a bit more manual work to do because obviously they will not be hosted by VMware. They will be hosted in your own data center. So you need to bring your own server and potentially ESXi licenses, and you will need to upgrade the gateways as well. but this gives you the unique ability to extend the power of SD-WAN between your shared services and your customers, no matter how many you have. Before I finish up, I also want to tell you that you need a certain subscription in order to use the gateways as part of the data plane. We use gateways as controllers for all SD-WAN deployments, so that's not a problem. However, if you are looking to use it for SaaS and infrastructure as a service, or you want to use it as a hub, you will need to run premium subscription on these edges. And by the way, I'm looking at the VeloCloud datasheet, which you can find on Google in case you want to revise this further.